Hello, welcome. This is Radical Operations. We're going to learn how to multiply, add, and subtract radicals. So, first of all, for multiplying radicals, it's important to remember that if we have the product of two radicals, radical A times radical B, in this case they're square roots, but they could be any index. I'll give you another example in a second. That's the same as radical AB, or the radical of the product. So if I have the nth root of A times the nth root of B, that's equal to the nth root of A times B. Just a brief example of this before we see some other examples. If I took the square root of 6 times the square root of 6, that's equal to the square root of 6 times 6, which is 36. And the square root of 36, you're asking yourself again in the square root, what number multiplied by itself 2 times is this number? And then in the case of the square root of 36, that'd be 6, because 6 times 6 is 36. All right, let's look at example 1. The square root of 20 times the square root of 5, because 20 times 5 is 100, this is equal to the square root of 100. And then I ask myself, what number times itself equals 100? And the answer is 10. 10 times 10 is 100. All right, moving on along. Number 2, we've got the square root of 6 times the square root of negative 2. Now, you got to be careful with this square root of negative 2, because you cannot take a negative times a negative is a positive, and a positive times a positive is positive. And so there's no real number that you can multiply by itself to get a negative number. And so the square root of a negative number has an imaginary I that comes out. So we're going to rewrite this as the square root of 6 times the square root of 2 times the square root of negative 1. These two right here, the square root of 2 times the square root of negative 1, are equal to the square root of negative 2. But when you separate them out like this, you can think of the square root of negative 1 as being the imaginary unit I. And then we can take the square root of 6 times the square root of 2 and multiply those together and get the square root of 12. Now, we want to see if we can simplify the square root of 12. We look at its prime factors. 2 will go into 12. That's the smallest prime factor. Goes into 12 6 times. 2 goes into 6 3 times. 3, it's prime, and so it goes into itself 1 time. When you get to 1, you're done. And because we're looking at square roots, we're looking at numbers that pairs of factors. And since there's 2 factors here, we can rewrite 2 times 2 is 2 squared. And so I can rewrite I times the square root of 12 as I times 2 squared times the square root of the number that's not in a pair, which is 3. So that's the square root of 3. 3 times 2 squared. 2 squared is 4. So you got 4 times 3 is 12. Everything's accounted for. But the square root of 2 squared is 2. And so I can bring that out of the radical as 2 times the imaginary unit I times the square root of 3. And that'd be our answer for example 2. All right, let's look at number 3. 2 times the square root of 3 squared. Now, because this is a product, another rule that we have talked about in the past is that if you have a times b squared, that's the same as a squared times b squared, or any other exponent. A times b raised to the n power is a to the n, b to the n. So in this case, we've got 2 squared times the square root of 3 squared. And 2 squared is 4, and the square root of 3 squared is 3, and 4 times 3 is 12. All right, and we're moving right along. Number 4. Here I have a sum. This is 5 plus the square root of negative 14. And so we're going to need to distribute that times that. The square root of 7 times 5 would be 5 square root of 7, or 5 square roots of 7, plus the square root of negative 14. I'm going to break it down into factors. That's the square root of negative 1 to get rid of the negative under the radical. The square root of 2 will go into 14, and it goes in there 7 times, but multiplied by this 7 out here is this 7 right here. This is square root of 7, because 2 times 7 is 14, times the negative 1 is negative 14. So everything's accounted for, but breaking it down this way is going to make it easier for us to simplify this. So I've got 5 times the square root of 7. These two right here, the square root of 7 times the square root of 7 is 7. So that's plus 7. The square root of negative 1 is the imaginary unit I, times finally the square root of 2. Now these are not like radicals. This is the square root of 7. This is the square root of 2. They have to have the same index and the same radicand, which is the number under the radical, in order for them to be combined in a single radical. So these are not like radicals. They have to stay separate like this. So that's our final answer. All right, number 5, I'm going to set this up using a box just to help us multiply. We've got two binomials, basically. There's this plus here and there's a minus here, and so we have what is like a binomial at the top of each of these. So I'm going to put 2 plus the square root of 6 and 5 minus the square root of 6 along the top. And then I'll multiply them out like times tables. 2 times 5 is 10. 5 times positive square root of 6 is positive 5 square root of 6. 2 times negative square root of 6 is negative 2 square root of 6. And then negative square root of 6 times the positive square root of 6, positive times the negative is negative. And then the square root of 6 times the square root of 6 is 6. So then I get, I'm going to pull everything out, marking those that are like terms. Go ahead and mark them in color here. 10 and minus 6, all constants without a square root are like radical, or like terms, if you will. And then 5 square root of 6 and negative 2 square root of 6 both have that square root of 6 with them. And so I can combine these in that way. 10 minus 6 is 4, and 5 rad 6 minus 2 rad 6 is plus 3 rad 6. And that's our final answer there. Okay, let's look how do we add and subtract radicals? To make a comparison, we've included this x plus y equals 5x. And we would say, hey, what you got to do is combine like terms. And then I'm going to cross out that terms and say radicals, because they work in the same way. If you have like terms, you can combine them. If you have like radicals, you can combine them. In this case, x and 5x are like terms. And so 5x plus x is 6x plus y. X and y are not like terms, so they can't be combined, and you would leave your answer like that. Well, if we look at number 6, this is very similar here. I'd say this one that's the square root of 2 and this one that's 5 square root of 2, those are like terms. And so imagine that when there's no number in front of that square root of 2, it's just like if there's no number in front of a variable, we can understand that number to be 1. So I have 1 square root of 2 plus 5 square root of 2 is 6 square root of 2, or 6 square roots of 2, I've heard some of my colleagues say. And then plus the square root of 3, and these are not like terms. The one has this 2 under the radical, the other one has the 3. They have different radicands, therefore they're not like terms, and they stay like this. It's true that you can add them. We've got this plus sign in between, but you can't combine them into a single term. They stay separate, like oil and water. Number 7. Now this one is a little bit different because we're subtracting. We're subtracting this term and this term here. So remember that subtracting an expression is the same as adding its opposite. And so we're going to have 3 square root of 2. And with that 3 square root of 2, 4 square root of 2 is its opposite, but it's minus, except that we're subtracting it. And so it becomes plus 4 square root of 2. We changed its sign. That minus 4 root of 2 became plus 4 roots of 2. And this 2 square root of 5 becomes, let's copy this one, minus a square root of 5 here, and then minus 2 square root of 5. Minus 2 square root of 5. And I've just lined up the like terms. 3 root of 2 plus 4 root of 2 is 7 root of 2. And plus 1 root of 5 minus 2. 1 minus 2 is negative 1, so I'm going to put negative. I'm going to choose not to write the 1 minus the square root of 5. Again, not like terms, so we'd leave our answer like this, and that would be our final answer for number 7. All right, let's look at number 8. You look at number 8, and you've got the square root of 12 plus 3 square root of 2, and you think, well, they can't be combined because they're not like radicals, and that's true. But if you look at 12, it looks as though it can maybe be simplified. So we're going to go off here to the side and write out its prime factorization. 2 goes into 12 6 times. 2 goes into 6 3 times. 3 goes into 3 once. And when you get to 1, you're done. Because we're looking at square roots, we're looking for pairs of factors or groups of 2. So there's 2 groups of 2. That's 2 squared. And so I can rewrite the square root of 12 as the square root of 2 squared times the 3 square root of 3. If you're ever wondering, have I got this broken down correctly, just look at it and think, hey, wait, 2 squared is 4 times 3 is 12. If it multiplies to give your original, then you're doing fine. So this is plus 3, plus 3 square root of 2. And when I simplify the square root of 2 squared, I get 2. So that's 2 square root of 3 plus 3 square root of 2. And lo and behold, they're still not like radicals. We've got the square root of 3 and the square root of 2. Those are not like radicals, so these stay just like that. That is your final answer. So we go over here to number 9. This time we've got some negatives under the radical, and so those are going to look like imaginary numbers when we've simplified them. I've got the square root of 5 plus 2 times the square root of negative 1 times the square root of 4 plus 3 square root of 5. Wait, I'm not going to write it right there. I'm going to write it over here. Plus 3 square root of 5, just because that way I'm lining up those that are like terms. Keeping track. Let's see, I've done that one, done this one. I didn't have to change the signs because this time we're not subtracting them, we're adding them, so it doesn't change the signs at all. And then we have plus negative square root of 25, and so I'm going to write that as plus the square root of negative 1 times the square root of 25. And here I get 2, the square root of 4. The square root of 4 is 2. This one right here is 2. Multiply the 2 in front is 4, so there's 4 times the square root of negative 1, which is the imaginary unit I, plus the square root of 25 is 5 times the square root of negative 1, which is that imaginary unit I. Now that I've got 2 that are the same, 4i and 5i are like terms, so I can write that as 3 square root of 5, the first term, plus 4i and 5i is 9i, and that would be our final answer. So if you find that you have additional questions, please ask your teacher. Come see me. I'm happy to explain myself further if needs be. Have a great day.